Okay, so we're going to be learning about geometric series. Here we've got some new formulas. And remember, a series is where you take a sequence and you just add up the numbers for so many numbers in the sequence. So here we've got two examples to start off with, 2, 4, 8, and so forth. So here I have a geometric series because we're multiplying by 2 to get from one thing to the next. Or in this case, you've got one where it goes from 1 to 1/2 to 1/4, so you're multiplying by 1/2 or dividing by 2, however you want to think about it, to go from one to the next. So the question would be, how would we find the sums of these things? How would you find the infinite sum, which we'll get to in a little bit? The formulas we have to work with are the traditional, specific, limited, or finite sums, and then you have the infinite sum. This formula works for any sort of equation you want to, any sort of sequence, because it has a specific number of terms you're going to add up. And literally, I could just find this many terms and make them add up, or I could let it go to infinity. However, I'll mention the A1 divided by 1 minus R is an infinite list. For example, if you were to take this example here, and if you did 1 plus 2, 1/2 plus 1/4 plus 1/8 forever, sometimes this value exists and sometimes it doesn't. Okay, you have to have a converging sequence. So your R value in this problem is 1/2, so it has to be less than 1 for this particular equation to work. If your R is 1 or bigger, then although you can make a number happen here, that sum won't work. Okay, so let's do an example. I've got down here for number 1. We're going to work out the sum of the first 8 numbers in the list. And so in this one, this is actually a little bit easier than in arithmetic because I only need really 3 things. I need the first number in the list, I need the ratio, and I need how many numbers I'm going to be working with. Usually, they're going to give you the first number in the list. That's pretty easy. And they'll probably tell you how many you're going to find. So you'll be left to find the R value, which in this case is pretty easy. If you take any of these numbers, 64 divided by 16, 16 divided by 4, 4 divided by 1, they're all equal to 4. So your sum of your first 8 numbers would be equal to 1 times 1 minus 4 to the 8th power divided by 1 minus 4 on the bottom. So if we do that math real quick, you're going to get negative 65535 divided by negative 3, which would equal 21,844. So 21,845 as your sum of the first 8 numbers in that list. Let's do the same thing, but this time let's do one where you have kind of a reducing fraction value here. So if we look at these, to find R, we're just going to take our values here, and we're going to take 3/2 divided by 3 over 1, right? And so I think it's not too hard to see what this is going to be, but this is the math you would do to get it. So that would be 1/2. And you will do that for each one of these. You'll see each one reduces when you divide to the fraction 1/2. So we're going to find the sum of the first 9 numbers. Now this is going to be a lot smaller because you're adding up really tiny numbers. So be real careful with your calculator. 3 times 1 minus your 1/2 to the 9th power. All that divided by 1 minus your 1/2. Again, I'm just using that formula from up top and plugging in my numbers. And so there you can see the math. You get 1533 on the top and 256 on the bottom. You don't get that number. It's obviously going to be a big number divided by, I think you get 2.994 divided by 1/2. But that fraction, if you turn your decimal back into a fraction, you'll get that number here. Or you can just kind of go with the decimal. You'll get almost 6, just a little bit under 6. Let's do one where it's an infinite sum. So we're going to kind of look at that example that we started off with, where you have, so example 3. This is going to be an infinite sum. So we start off with 1 plus 1/2 plus 1/4 plus 1/8 plus dot, 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 right? So this is asking, and it'll be specific to find the infinite sum. In this case, there will not be an n, so we'll be using this s equals a1 divided by 1 minus r, right? And so it's going to be 1 divided by 1 minus 1 half. That's actually relatively easy. You're going to get 1 over 1 half, which turns out to be 2. So if you let the numbers 1 to 1 half to 1/4, if you just let those keep going forever, if you add them all up, eventually the number you're adding to the total sum again becomes so incredibly small that it doesn't ever affect the sum again. And that's what we call an infinite sum, right? Usually you'll see here you have just s. There won't be an Sn. It's just s by itself. Sometimes I'll add an infinity symbol there just to kind of make sure that you understand what that is. So make sure you know that. And that's all you have to do. That's actually a relatively easy thing to find. Just make sure you get the r for each one. And that's also not too bad. And this is essentially how you would find the sums of a couple of different sequence types.